when you have an inequality, you don't have a single answer to something. You have a set of values that, that form its solution. For example, if you're looking for a job and you want the job to pay, $12 an hour or more, there's not just one value that you're looking for. You're going to, of course, consider jobs that pay more, $14, $15 an hour. And so in order to completely solve inequalities, we need to describe their solutions as sets. Okay, so in the, we'll talk about some notation here where we have x's between a and b, and it's possible that we want these to be limited to a and b, sometimes include a and b, sometimes not. So this means that x can be either a or b or someplace in between. This one here means it can be anywhere in between a and b, but not a and b. So if we look at how to graph this, the traditional way that we do it is using a square bracket on the ends that signify an equality. We'll use a parentheses or a curved line to represent not including that particular number. Now you may have learned how to do this with a dot colored in, meaning the equality, and then a dot with a circle not colored in as being the strict inequality, where the equality is not part of it. Either way you do it, whatever you're used to is fine. I have no preference one way or the other. Our book looks like this. Once we start doing intervals with two-dimensional graphs, then it's almost always done with either solid dots or hollow dots. And so I think from the standpoint of just graphing on a number line, this is probably a little bit easier, but certainly both of them are acceptable. Okay, so the way we're going to signify this with intervals is we're going to use the same symbols that we use graphically. We'll use the square bracket, or we'll use parentheses to indicate which side has the equality and which side is the strict inequality. Like this one is just parentheses. Now, unfortunately, mathematically, we don't have a lot of symbols, and so we reuse symbols. So occasionally when you see this, like let's say this is 3, 2, is that a point on a two-dimensional graph, or is it an interval on a single-dimensional graph? And so it's ambiguous there. So you do have to lend some context to things when you're writing intervals. Like it's okay to say the interval, or whatever, or make it clear somehow that you're talking about essentially a graph only along. We're talking about an interval, a graph along a line, not a point on an XY graph. Okay, an alternate way to do this is that we can write set builder notation. Now, set builder notation looks complicated, but it's actually way easier than it looks. This brace here is almost always used to indicate sets, okay? And that's one of the nice things that we don't have to worry about many meanings of this thing. You almost always use this to indicate a set. So you read this as the set of. You put in a variable, so we're talking about x maybe. And so we have the set of x, and then we describe what x is. And this vertical line here, which is on your keyboard, it's on the second line all the way on the right, means such that. So we read this as the set of x such that x is between a and b. Okay? So this is really a very convenient notation because there's really very little rules for putting in, very few rules of how you describe what x is supposed to be. You can make a whole laundry list of things. X is greater than 3, x does not equal 10, whatever it takes to describe the set that you mean. So this is a lot easier when you have multiple intervals here. You have to start doing the unions and intersections and all that kind of stuff. So this one perhaps is simpler for the simplest ones, but this one ultimately is simpler for the complex ones. Okay, you should be comfortable writing both of them. Now when we have inequalities that aren't bounded on both sides, if we say x is greater than a, or x is greater than or equal to a, or it's less than b in this case, the way we plot this, and I guess I did do this completely. You make the lines with the indicator, and then you also put arrows on these to indicate that these go off indefinitely. You don't see that arrow very well, but you can see my other arrows. And write these intervals using infinity for the side that it increases or indefinitely, or negative infinity if it's going to be ever decreasing numbers. Now, you always use the parentheses with infinity, because infinity is not a number. You never reach it, right? Infinity is a concept that means this interval increases without bound. All right, so it's an idea. It's not a, well, a number is an idea, but it's a different idea than a number. This means that x can increase without a bound. This means it decreases without a bound. Okay, so always use the parentheses when you're dealing with the infinities, and always put them in order, smallest to largest, left to right. Okay, so this is suggesting that a is the bottom value and it goes up. Here, b is the top value and it goes down. If you want to say all real numbers, you can do it like this, negative infinity to positive infinity, or a perfectly good symbol that means the same thing is this r that looks like this. Okay, and that's the way you write it, and you'll see it in your textbook. It's like a bold R that's not colored in. You know, it's kind of a unique script that they use for this. And this means the set of real numbers. So you don't have to put this in braces or anything like that, because then you're going to be really notating the set of real numbers. So you read this R as just the set of real numbers. So if all numbers work as a solution, you can just write R, and that means it's the set of real numbers. Okay. So I think just in the interest of time, and I think this is an easy enough exercise where I'm just going to show you this. So we have these values and we want to graph them, and they'll look like this. Less than 4, it includes 4. This is less than or equal -3. This is between -3 and 4. Doesn't include the 4, but it includes the 3. Okay, so we're going to have a concept here about lengths of intervals and also distances between two numbers. We're going to consider whether you have a bracket or a parentheses. It's going to be the same length. Okay, so the length of this interval is 6. 10 minus 4 is 6. The length of this interval is 13 minus 5, or 8. Okay, so we're not going to indicate anything that, you know, just because we're missing the value 13 itself, we get everything up to it. So from a talking point, we're talking about the length as being the same. So we just take the higher number and we take the difference, and that's going to be the length. So here we take 4 minus a -2 and we get 6. So we look at the length of that interval, and that's 6. Now we have some properties of inequalities. If a is less than b, we can add or subtract whatever we want to either side, and it always works. So if I have 3 is less than 5, then 3 plus 10 is less than 5 plus 10. Okay, so there's nothing tricky there. It works just like an equality. Now, if we have c as a positive number, a non-zero number, if a is less than b, then we can multiply either side and or divide either side, and we retain the same relationship of the inequality. So again, if a is 3 and b is 5, c can be 10, so we have 30 is less than 50, or 3/10 is less than 5/10. So that works as expected. Now this is something called the transitive property of inequalities. If a is less than b and b is less than c, then a is less than c. So if my youngest brother's age is a, my sister's age is b, and my age is c, if my youngest brother is younger than my sister, and my sister is younger than me, then my youngest brother is younger than me, right? Okay, so this is not a complicated idea, but it just notates out to something that, you know, is perhaps a little more complicated than it looks. Okay, so let's look at solving one of these. And there's 2 ways to solve it, and we're going to get exactly the same thing. We have x plus 3 is less than 0. So I'm going to subtract 3 from both sides. and I get x is less than negative 3. If I'm going to subtract x from both sides, I get 3 is less than negative x. So I'm going to take these two and I'm going to compare them. And look what happens. If I take this one and multiply the whole thing by negative 1, so I get negative x and positive 3, the sign or the direction of the inequality changes. So now when we go to do something and we're multiplying by negative 1 on both sides, we have to change the direction of the inequality. And so what I'm showing you here by using a property that doesn't look strange, I'm showing you that the property actually exists where now multiplication of negative numbers, we have to be concerned about the direction of the inequality. Okay, so then here it is. If C is negative and A is less than B, we multiply both sides by C, we get AC is greater than BC. Now think about, let's just put in some numbers. Let's say C is negative 1. Let's say A is 2 and B is 4. So if 2 is less than 4, we multiply both sides by negative 1, we get negative 1 is actually greater than negative 2. This is just a reflection of the fact that on the number line from 0, the magnitudes of the numbers increase, but a large magnitude negative number is actually a smaller number than its counterpart, okay? Than numbers that have a smaller magnitude. In other words, negative 5 is less than negative 3. And so this basic relationship is important to know, because as you're flipping around to the other side of the number line, you're actually reversing directions, and that's what that negative represents. Okay, so let's solve one of these. This isn't any rocket science. So we just basically subtract 3 from both sides. We get x is less than 1. So we can write that as, if I wanted an interval notation, as negative infinity to 1, not including the 1. So we'll get progressively more difficult. 3x plus 7 is less than 2x minus 1. So the first thing we do is we're going to subtract both sides by 7. And so we get 3x is less than 2x. And so we'll subtract 2x from both sides, and we get 3x minus 2x is just x, and then the 2x's go away, and we get just negative 8. So we get x is less than negative 8. Now, as a basic strategy, when you have x on both sides, what you should do is, as you're simplifying this or solving this, is go to the side where x is going to be the largest. Okay, so 3x is larger than 2x, so we want to move everything over here. If we have this as negative 3x, and that's 2x, then you want to move all your x's that way, so you get a positive x. And then you avoid even the question of, do I have to multiply by a negative number, because the coefficient in front of x will always be positive that way. So that's just kind of advanced planning that you can think about. Okay, so here's one for you. Why don't you try this one? Yes. Okay. Negative 3?
Oh, I'm sorry. Wait.
Anybody else have an answer? Yes.
X is greater than or equal to
7. Okay, that works. Okay, so let's look at this step by step. So since my x is negative, I'm going to add x to both sides, so I get my x is positive over on that side. So I'm going to add x. And so the x's disappear, and I have 5 is less than negative 2 plus x. I'm going to add 2 to both sides, and I get 7 is less than or equal to x. And that can be written just as easily, x is greater than or equal to 7. And in fact, this is kind of like Yoda speak. It's kind of backwards. When you say 7 is, what's the value of x? Well, 7 is less than or equal to x. Well, probably a little bit more natural way to say that is x is greater than or equal to 7. Either way is okay, though. Okay? So here's another one.
Is that a z?
That's a z, yes. Thanks for bringing that up. Contrary to the way I learned Catholic grammar school, I don't loop my 2's, so they look like a Z, and so I make my Z crossed. Sister DNA would really, really scowl at me for this. Okay. How do we do? Okay? Let's look at the answer here. Distribute the 2 and the 8. We have the bigger coefficient on Z, so we'll move all the Z's over there, and we get add 2Z to both sides. So we get 8 is greater than 8 plus 10Z. Subtract 8 from both sides, and so you get 0 is greater than or equal to 10Z, and so 0 is greater than or equal to Z. Now, one of the ways that you can notate things, and you've already seen this with the first slide, is that you can use 2 inequalities, and this only works if the inequalities point the same direction. You can have one a strict inequality and one just a regular inequality with the equal sign. That's not a problem. So in other words, I can make this less than x and this is less than or equal to 6. But they have to go in the same direction. It's not going to make any sense if you say this is bigger than that, which is smaller than that. That may be true, but it's just not very helpful to write the notation. So you generally use this to indicate something is between 2 things. Now, you can split this apart to solve for -3 is less than or equal to x plus 2, and then you can say x plus 2 is less than or equal to 6 and solve those separately, but you don't have to. What you do is you target the middle part here. You want to solve for x, and you don't want to move x to the outside. Okay, you might be tempted to do that sometimes, but always keep the x on the inside and just kind of strip away all the other numbers. So here we're going to subtract 2, and you subtract 2 then from all 3 of the segments here, and so we get -5 is less than or equal to x, which is less than or equal to 4. And when you come up with these, make sure they make sense. You might have made a mistake somewhere along the way and say -5 is greater than or equal to x, which is greater than or equal to 4. Think about what you're writing in terms of its meaning as well as just cranking through the mechanics of these things. Okay, here's another one where it's a little bit more complicated because I have a -7x in there. So the first thing I'm going to do is subtract 4. And then simplify that. And then what I'm going to do is divide by -7. Now remember, when I'm dividing by a negative number, I have to switch the direction of my inequalities. Okay, so here first I divided by 7, then I divided by -1. So I did it in 2 steps. You can do it in 2 or 1 if you like. And so they're reversed. And this is a perfectly good inequality, but usually or traditionally you go from the smallest to the largest. So you can reverse this to say -6/7 is less than x, which is less than or equal to 2. So make sure you swing the whole thing around, that you're just not changing one and not the other. And then also make sure that you honor the whether it's a strict inequality or whether the inequality has the equal sign with it. So here, when I swapped it around, I kept the strict inequality. Okay?
Why did you swap it?
I swapped it just because it reads better.
Oh.
You go from smaller to bigger, and that's the way you write an interval and all that. Strictly speaking, this is correct. And there's nothing really wrong with this. It's just that this is kind of the flow. You always go from smallest to biggest. I wouldn't ever mark you wrong if this was read right. I mean, just based on transposing those. Oh, you know what? Here, I have one for you to try, but I'm actually doing it for you. So, my sense is most of you are getting this. I mean, this isn't... Okay, so here I'm going to subtract 4 from all of them, and then I'm going to end up with a negative 2x, so I'll divide everything through by negative 2x, and I've swapped the direction of the inequalities, and so then I have 5 is greater than or equal to x, which is greater than negative 2. Turn it around, negative 2 is less than x, which is less than or equal to 5. Okay, now it's possible, well, with absolute values, we're going to run into something that's called a compound inequality. So we're going to use the words and or. So we'll have 2 different statements, inequalities, and they'll either be joined by a or they'll be, connected by an and. So, for instance, if I say 2x minus 4 is less than 4 and 2x plus 8 is greater than 6, I have 2 conditions that I'm looking for. So imagine this room. Let's say the width of the room is 20 feet, okay? What I'm looking for is I want everything that is inside the wall. So I want it this side of the wall here, and I want it this side of the wall. So anything that is within that space, I want both rules to apply. So just because I'm on this side of the wall, I also have to check where I'm with respect to that side. So ands mean that both have to work. So let's solve this. And so what you do is you work these separately and keep the and in place. So we're going to add 4, and then we're going to divide by 2. So we know that x has to be less than or equal to 4. And so when we do this side, we're going to subtract 8, going to then divide by 2. And so x is less than 4, and x is greater than negative 1. Now the ones with and are the ones that you can connect. I'm not sure if I actually write that here. Yeah, I do. Okay, so I can say, okay, it's greater than negative 1 but less than 4, so I can connect them like this and say negative 1 is less than x, which is less than 4. So it's always going to be this kind of interval that you have bounds on the outside. If these were swapped around, you could have no solution. Sometimes, if it has to be less than negative 1 and greater than 3 and greater than 3, that doesn't work. So you indicate no solution. So that's what I'm going to do here. 2x plus 1 is greater than 3, and x plus 5 is less than 2. Subtract 1, subtract 5, and so I get x is greater than 1 and x is less than negative 3. Can't happen. There's no number like that, right? So we're going to just then write no solution. Now, we have the other case of or. This is the same basic equation, but we're going to put an or here. And so x is greater than 1 or x is less than negative 3. Now, that's quite well possible. You could be one or the other. In fact, you could only be one or the other with these intervals. So we write these as intervals with the union sign. And the union sign is a way to say or. All right, let's shift gears a little bit and talk about absolute value equations and inequalities that involve absolute values. So if we want to solve this, you know what this means. The 2 vertical lines means that you're going to take the positive version of this side of this number. So if x equals 3, absolute value of 3 is 3. If x is negative 3, the absolute value of negative 3 is 3. So there, I've just told you what the solution is. Then we have an or condition here, where we have an absolute value and an equal sign, you always have an or. So what's going to happen is either the absolute value is going to leave the value alone and you get x equals 3, or it's going to change the value of x to the additive inverse, and so then when you multiply both sides by negative 1, you get x equals negative 3. Now this little step here, you do every time, but you don't have to write it. You can write this, and you'll see as we go along. Here's one that when we solve it, we have, if what's inside here is less than 0, then this is going to be the negative version. If what's inside of here is positive, it's going to leave it unchanged. And so when we write our OR statement, we start with this, and then we can solve x equals 2 or x equals negative 8. Now you can do this right here. We usually skip this. So when you translate your absolute values into two different statements, what you generally do is take what's inside of the absolute value, leave it unchanged, write equals, and then the negative of this value here. So this line this line here you typically won't see, or you don't have to write. And that's probably the way you learned it in high school, all right? Okay, so try this one. Very straightforward, easy one. Now sometimes on exams, and as you're working on this, I'll make a couple comments. Sometimes on exams I'll see people go through a whole set of problems with absolute values and not once look at two cases. And you know, if it's a 4-point problem, that's really going to be just 1 point. Because part of understanding of what's going on here is that it can take on two different values. And so it's not just, do you get half the answer and get half the points? That's not right. You get less than half because you missed the most important concept about what the problem is. Okay, so we have this. You probably can write that as fast as anything. So we have x plus 1 equals 6, or x plus 1 equals negative 6, x equals 5, or x equals negative 7. One of the things that you have to do with these is that you have to check them. Go back to the original equation and check them. And the reason why you do that is not to catch your own mistakes. You know, it does, you know, get you, allow you to correct your own mistakes. But it's possible you have a situation where you've done everything perfectly and it doesn't work out in your equation. And what you end up with is what's called an extraneous answer. So your computation was right, your algebra was right, but you test the solution and it's actually not a solution. And if you really examine those kinds of cases, you'll see what happens. You know, generally a sign changes where you wouldn't expect it to change or something of that sort. You'll see a few of them in your homework. Okay, so this one's a little bit more complicated. Try that. Okay, anybody get an answer?
A is equal to 2 over 7, or A is equal to negative 2.
Okay. When A is 2 over 7, 2 over 7 times 7 is going to be 2. 2 plus 6 is 8. 8 divided by 4 is 2. So you're right. The other answer you gave was?
Negative 2.
Negative 2. So we have 7 times negative 2 is negative 14. Plus 6 is negative 8. Negative 8 divided by 4 is negative 2. Absolute value of 2 is 2. Absolute value of negative 2 is 2. Okay, so very good. Now, the key thing that I want you to know about these things and about handling these is, there it's worked out, and you're going to have both the recording and the notes posted after class. So the key thing that I want you to know about this is do not do operations that remove things from inside the absolute value to the outside first. Sometimes you can get away with it if you're really careful about it. Sometimes you really make a bad mistake. So I would say don't ever do that, okay? And so like always, we check our answer. I did that orally when you volunteered your answer. And so we're good. So let's talk about more general equations that have an absolute value in them. Okay, so that means we can have stuff all over the place. It's not just an absolute value equals something else. But what you want to do is you want to make it that way. So keep the absolute value as an entity. You're not going to touch what's inside of there, but move everything possible over to the other side. So in this case, what you'll do is you're going to say, okay, first thing I'm going to do is add 6 to both sides and get negative 2 plus 6 is 4. Then I'm going to divide by 2. Okay, and now this looks like a familiar problem because we have an absolute value expression equals something else. Okay, and then we can solve this in the normal way by expanding this into two different equations connected with an OR. All right, so fairly mechanical here. On this one, we're subtracting 4 from both sides, dividing by negative 3, and we get 2/3 there. This one, we're going to subtract 4 from both sides, and then divide by negative 3, and we get a 2. So then we check both answers. Now, it seems like a lot of work sometimes, especially when you get a fraction. You know, you start with something that doesn't have a fraction in it, but you end up with a solution with a fraction, and so your computation is going to be, you know, tempting to leave it alone. But here again, it may be possible that you get something that doesn't work. Okay, and this is my my big caution to you: don't ever do this. Take the absolute value of the negative 6, because if this expression, this is the expression you're talking about, if x is 2, then 2 minus 6 is negative 4. Absolute value gives you 4. In this expression, if I put the 2 in here, I get absolute value of 2 plus 6, I get 8. So it doesn't equal. It's possible that it equals, but that would be a coincidence. Okay? Just don't ever do that. That's really, really bad math. Okay. Now, another class of problems that we'll run into is when we have two absolute value expressions in one equation. So if A and B are expressions, you could end up with something, the absolute value of this equals the absolute value of that. And so when you go through that analysis that I did before of, you know, A, it's either A or negative A, you know, that kind of stuff, how do we switch around the signs? There's actually 4 different possibilities here. A equals B or A equals negative B. We're used to that one. But then it could also be negative A equals B or negative A equals negative B. But take a close look at this with the equal sign, that if we multiply this by negative 1, we'll get this. So these are the same thing. If we multiply this by negative 1, we get negative A equals B, and that's the same thing. So there's really only 2 cases, even though we have 2 different absolute values signs that, you know, maybe at first blush you think you should have 4 cases. So here's an example. So the way you set it up is write it, assuming that the absolute values don't change anything, and then write it so the absolute values change only one side. Now, don't jump ahead of yourselves and say, okay, this is going to be negative 3x plus 6. What I suggest you do is take the absolute value sign, replace it with parentheses, and put a negative in front of it, because now you have the equation, kind of the less you do, the less chance you have of a mistake. And, you know, if I gave you 100 of these, and let's say you had an error rate of like 5%, I would say almost all of the errors come from the fact that this negative sign and this negative sign aren't treated properly. Okay, it's always the negative at the end of the equation, because You're cooking along, you're feeling good, you know what to do, and you forget it. And I know because I forget it too. Okay, so when you're doing these kinds of things or anything that involves distributing a negative sign, if you only have a little bit of chance to look back at your work, always look at the last term because that's the vulnerable place. It's not because you don't understand it, it's just because that you know, if you're going to trip, that's where you'll trip. Okay, so I'm going to solve this and the usual way. So here I'm going to add 6 to both sides, and then I'm going to subtract x, and I get x equals 4. Now here's my little caveat. And so x equals 1, and then we're going to try it. We'll put it in the expressions, and sure enough we get absolute value of 6 equals absolute value of 6. And on this side, where you put in x equals 1, we get absolute value of 3 equals absolute value of negative 3. Lo and behold, we're good. Okay. It's possible that you end up with extraneous solutions, so I can't emphasize this enough. Check your work, okay? And it's not a failure on your part if you end up with only one solution working. It's just the way the problem is. Okay, so go ahead and try that. Yes.
So these notes will be available after class, right?
The homework is already. Oh, the notes, yeah. I'm going to post this right away, and then the recording will take me a little bit. I have to go real fast, so recording may be like before dinner or something like that.
But like these ones?
Yes, definitely.
Okay.
Okay. Hopefully you've at least laid it out at this point. So I'll work a little bit, kind of overlap with what you're doing. So we first write it by removing the absolute value signs, and then we write it so we're going to keep parentheses where the absolute value signs were, put a negative in front of it, and then we'll simplify and solve. Okay, so here we're adding 3x to both sides, and then we're subtracting 1, and we get x equals 0. And here what we're going to do is distribute the negative, and then we're going to add 1 to both sides, subtract 2x from both sides, you get x equals 2 or x equals 0, and they both work. Okay? Everybody get that?
Yeah.
So the key step is making a statement that is connected by ors. Okay, so make sure you set yourself up so you don't make an easy mistake there, a mistake that you no doubt understand. Okay, try this one.
Is it a 4 or 9?
I'm sorry, that's a 9.
Okay.
Okay,
Thank you.
sorry about that. When you get an answer, raise your hand, okay? Yes, what'd you get?
Would it be x is equal to 2 or x is equal to 4? And I don't think it works if that's...
2 times 2 is 4 plus 7 is 11. 2 times 2 is 4 plus 9 is 13. That one doesn't work. And you also said 4.
Yeah.
So that makes 8 plus 7 and 8 plus 9. They don't equal each other. Okay, so something went wrong on you. Okay, anybody else get an answer? Yes.
Well, for one of them, doesn't like the x's cancel out? You can't find the answer for one of them.
So there's no solution on
Yeah.
one of them, okay?
And then negative 4 for the
And negative 4, okay. 2 times negative 4 is negative 8 plus 7 is negative 1, which makes 1. And then, I'm sorry, what did you say?
negative 4.
Negative 4, this is negative 8 plus 9 is 1, and so we have absolute value of negative 1 equals 1, and we're good. So in the notes you'll see the solution there. Not a solution, because 7 does not equal 9, that's a contradiction. And so we try it out, and certainly enough, we have 1 equals 1, and so here's one that you only have one solution. Okay? Now, on these, when I give them to you on a test, don't just not write this, because maybe on scratch paper it doesn't work and you think not a solution. You only write this and you only say one solution. You have to demonstrate to me that there's only one solution, because these potentially have two, and you have to rule out that you only have, you have to rule out the one that doesn't work. Okay, so now let's go through absolute values with inequalities. And the first thing I want you to do is look at the difference between two numbers, its absolute value, as a distance from A to B. Remember when we had the length of the interval, we took the larger number and subtracted the smaller number from it, we get that length. It doesn't matter which one we do first if we just take the absolute value. If we take the difference of them, we'll get the same distance, okay? So that's, again, like me measuring this table. If I take my tape measure, up 48 inches. If I go this way, it's going to be 48 inches as well, okay? And so the difference between two values, the absolute value, distances are always positive. Okay, so let's look at this. So this one you already know how to do. And so I'm going to set this up as x minus 6 equals negative 3, so x equals 9 or 3. Now let me put this on a number line, and let's visualize this. So we have 6. So we're looking at a number. We're looking for all the numbers whose distance from 6 is 3. And that's a physical meaning of what this equation is all about. So if this is a distance, you see the distance of x from 6 equals 3. All right, so I have two solutions, one on one side of the point and one on the other side. And in fact, that's probably the best way to look at some of this stuff. Okay, so I think this is what I just said. Can be thought of as the distance from x to 6 is 3. Okay, so let's look at an inequality now, where this one means that this distance is more than 3. Okay, so see if you can imagine what that number line looks like, that the distance from x to 6 is more than 3. So it's going to work out the same way, but it's going to be either this interval here or this interval. So the thing to remember is that when you have a greater than sign with the absolute value on the left side of the equation, that this is always going to be an or. Okay, it's an or, because it's just like me standing in the room where the walls are the boundaries. If you're farther away than the wall from me, you're either on that side or you're on that side. You only have to meet one condition to be farther than the distance to the wall. So this is the way we do it. We write it as usual, and then we use an or. And this is going through kind of the theory of this, where I'm going to say, okay, the absolute value can change the sign of this expression, but if I look at what it really does is I can multiply it by negative 1, and so I'm changing the sign and making this negative. So you don't have to do this particular line. Just go right to this, where you're going to take this, which is this equation without the absolute values, And then, or, you're going to take this where you're going to change around the inequality and make that negative. Okay, so when you solve those two, we get, by adding 6, we get x is greater than 9. And here, when we add 6, we get x is less than 3. And so that's what my diagram shows. So the physical meaning of this is that the distance of x, whatever value x is, the distance from 6 is greater than 3. Okay, so the greater than is or. Okay, so let's look at the other one. The distance is less than 3. Now this is my room example again, where if I'm looking at distances that are less than 10 feet from me, if this is a 20-foot room, that means you not only have to be to this side of that wall, you have to be to this side of that wall again. So there's 2 criteria that you have to meet. So when you split these up, you're going to use an and, because both of them have to work. Okay, so here again, same basic equation, different equality sign, so I'm going to be within. So that less than, the absolute value less than some other value is this difference, or this distance, is within a certain value. Okay, so here I'm going to just directly do it. I'm not going to go through that step of making one side negative and then moving the negative. So I have x minus 6 is less than 3, and you just have to remember, okay, and then you change the direction of the inequality and you make the right side negative, and you get x is less than 9 and x is greater than 3. So you can write this as 3 is less than x, which is less than 9. Okay, and that's what we have. So we're within a certain value, within a centered value. And of course you should check. Now, when you're checking inequalities, you can check the boundaries of them and it turns out to be an equality. But what you don't know is, did you get the right sign? Okay, are you less than or greater than? So what you do is you choose, in this case, we can try a 4 or we can try a 7 and it should be true, or we can try a 1 and it should be false. Okay, so if I put a 1 in here, 1 minus 6 is negative 5, absolute value of negative 5 is 5. 5 is not less than 3, so it failed. You expected it to fail. If we choose 7, 7 minus 6 is 1, absolute value of 1 is 1, which is less than 3. So you can check the boundaries, but you're checking the equality when you do that. If you check something that's within the interval that you're interested in, that will tell you if you have the direction of the inequality correct. Okay? Almost there, please. Big yawn, right? Okay, so try this one. Get an answer? Think so? How confident are you?
One's kind of confused by the bracket.
Oh, with the inequality?
Well, is that just on the regular line or a bracket?
There's no bracket here.
Okay, all right.
These are
Okay,
absolute
well,
values.
Okay, my answer is x equals 2 and x equals negative 2.
But you're saying equals now. It has to be
Oh.
an inequality, right?
Yeah.
Okay. Let's go through this here. Okay, so we're going to write this without changing anything. And since this is a greater than, it's going to be or. And so we have 7x minus 3. We're going to change this around to less than, change the sign of this, and then solve them. So we add 3, divide by 7. And then we're going to add 3 and divide by 7. And so we get 2, x is greater than or equal to 2, or it's less than negative 8 over 7. Yes?
So basically, if it's more, you use or, and then less than and.
Yeah, and you know, I've never figured out a way to to how to memorize that, but just when you're saying that, it just occurred to me, more and or, right? So if it's more, it's or. Okay, so that might be a good kind of way to recall, and then less than is the other one, so that's, that will be and. But more is or, I guess, is just right.
Nice.
Okay, so how do we test this? We can test it in a number of ways. If we put in the 2, we'll get exactly 11 equals 11, okay? And if we put in the negative 8/7, we'll get exactly the same thing. 11 is equal to 11. If you go a little further and you say, okay, what is greater than 2? That's easy to compute. Okay, 10. Okay, so 10 should be part of the solution. So if I stick a 10 in for x, it should be true. So this is 70 minus 3 is 67, right? 67 is greater than 11. So I know the direction of my inequality, at least here, is right. Then I can put in something less than 8/7, and so I put in negative 10. Okay, so if I have negative 10, this is negative 70 minus 3 is negative 73, absolute value. 73 is greater than or equal to 11. So we got both of the directions of the equalities right, of the inequalities. Okay, we have like 2 minutes, so I'm just going to run through this one. Now, here the rules apply, just what I had before. If you have things in your left-hand expression that are not inside the absolute value, first take care of them. So in this case, we're going to multiply both sides by 4. And so this is less than, so it's going to be and. So these are the two equations that I set up. Less than 120 and greater than negative 120. And so when I do my math, I get this interval. And then we check it. So it's bigger numbers to check, but nevertheless. We know the equality part works, but we know the boundaries. Now this is equal. It doesn't say equal here, but at least I know that my boundaries are right. But I know that 0 is somewhere in this interval. So if I stick a 0 in here, this must be true. And 0 is a good test number. Like if you're looking at an interval and it happens to be within, 0 is within this range, pop a 0 in here to see if it works. 0 minus 16 is negative 16, so that becomes positive 16 divided by 4. So we have 4 is less than 30. You got the you got that part right. Okay? All right. Have a very safe weekend.